The Raspberry Pi is a portable, complete computer. We are going to make a project using the Raspberry Pi as a communication link. There are going to be 3 devices connected to the Raspberry Pi to build a complete system for the robot. We will begin with the robot. So basically we know that the Arduino is the brain of the robot with attached sensors to detect any obstacles along its way. These sensors will send data to the Raspberry Pi, and the Raspberry Pi will then transmit its data to other devices. The Arduino is connected via the USB port to the Raspberry Pi. Moving on to the Nexus 7. This device is responsible for starting the robot as well as manually controlling the robot when needed. It can also display the actual location of the robot on the simulator. Nexus 7 uses the Bluetooth signal to connect to the Raspberry Pi. The next device is the PC client. The PC will receive sensor readings from the Raspberry Pi and map it onto the simulator. The algorithm will then send a command per sensor reading to the Raspberry Pi. Upon reaching the goal, the algorithm will calculate the shortest path for the robot to go back to the starting point. The PC is connected to the Raspberry Pi via Wi-Fi. And the end result will be for the robot to traverse through the maze and avoid obstacles along the way.
Hi, I'm Jiang, and I'm the leader of Team Robot. And my job is mainly focused on the functionality of the robot and handling the Arduino board.
We are the PC team. I'm Amanda and I'm doing the shortest path algorithm.
Hi, I'm NIRMALA. I'm doing the PC simulator.
Hi, I'm ISABELLE and I'm doing the socket connection on the PC.
Hi, we are from the Raspberry Pi team. I'm Chung Sang and I'm doing the configuration for Raspberry Pi.
Hi, I'm JIANG. I'm doing the communication link among PC, Nexus, and Arduino.
Hello, we are from Android teams. My name is Chirstiansands. I'm handling the Bluetooth, toggle button, and the back.
And I'm ISABEL. I'm handling on Bluetooth, UI design, and control buttons.
Raspberry Pi seems to be minor to the project, but actually the impact can be surprising. Raspberry Pi is very critical to the entire performance. Once the Pi is down, all communication links are cut off.
The biggest challenge that we face is during the integration of the Raspberry Pi. Since error can only be found during the testing phase, we need every devices to be connected for the data interconnection. Otherwise, testing cannot be done, and we couldn't refine on the scheme of the Raspberry Pi that we currently designed.
At the beginning of our progress, we developed a simulator for the robot to simulate a robot traversing an unknown area. We can observe how a robot will react to an obstacle along its path and avoid it.
The next phase will be for us to connect the Raspberry Pi to the PC. This two-way connection will enable the Raspberry Pi to send signals to the PC and the PC to send commands to the robot via the Raspberry Pi.
After we have done the connection to the Raspberry Pi, we will explore an unknown area and compute the shortest path for the robot. The robot will then follow this path back to the starting point.
During the initial development, we need a control robot to traverse. So we created an integration XIII to control the movement of the robot.
After the connection to the Raspberry Pi is done and the algorithm is up, the Android functions will adjust accordingly to the pin needs to make the task easier.
During the robot assembly period, initially we using the default setting of the motors, but we found the issue the robot cannot go straight and will always turn one side. It's due to the two motors cannot rotate at the same speed even we set it at the same power. So we developed our own programs to counter these issues. So we developed a program can monitoring the speed of the two wheels to make sure they can rotate at the same speed. So it detects the robot can go straight, but the new issue happened. It cannot go accurate for a target distance. So in the end, we are selecting to use the PID control libraries to helping us control the motors. So by setting the difference P, I, and D constants, we can get the robot to move straight and accurate.
From assembly of every robot component.
From the integration of every devices.
From controlling and monitoring the robot.
From exploring an unknown environment.
For all the time and effort spent.
We overcome all the obstacles. We made it!